take a look at the Temp Select Electrical Compressor Control System Scanner. Now what you're going to get with this kit is the tester itself, which you see it's got two clamps. You're going to hook that right up to the battery leads to power up the tool. And then there's a couple leads in which you're going to find the appropriate male and female connector. There's over 20 of them included with the kit, so it should plug in directly to your compressor and to your harness. And what this is going to do, it's going to save the technician time and money by quickly determining if an AC service job has a computer control or a refrigerant system issue. This is going to allow you to manually drive the compressor to full range displacement performance for accurate test results. Why would we need this tool? Well, with electronic variable displacement compressors, there's no clutch turning the compressor on or off. There's a variable displacement control solenoid, which is commanded by the vehicle's control modules. And what this is going to do, when pressures need to increase or the compressor is turned on, requested to pump more refrigerant, that control solenoid is going to change a swash plate inside the compressor. Now, depending on the demand from the vehicle, that swash plate is going to change the angles. So with higher demand, that plate is going to be at a higher angle, and the computer is going to control the solenoid via increased duty cycle. So quite often, the technician has no clue where the problem is. We don't know if the computer is actually commanding it or if the compressor is actually doing the job. That's where a tool such as this comes into play. Sure, you could use a lab scope and back probe it to read the control there, but it doesn't allow you to manually control it yourselves. Being a scan tool guy for many years, I always thought the scan tool could do that. Well, let's take a look at a scan tool here a second and see what that gives us. Over the years, many technicians have been taught to use the bidirectional controller scan tools to test outputs of control modules, and rightfully so. We want to use the scan tool to command a component to turn on or off. And that's what we'd hope to do with one of these variable displacement compressors. Well, on this Chrysler 200 that I'm using for an example here, I've got a hold of the Chrysler Y-Tech scan tool here. This is the factory scan tool for this vehicle, and I've selected PCM. There's an HVAC control module here as well, but that controls most of the blend doors and temperature actuators, not necessarily the compressor. So we're in the compressor view here. So we're in the PCM view here, and we are going to look at the actuators. Now there's a huge list of different components which we can actuate here. And there actually is a AC clutch relay control state. Now since there is no clutch on or off on this particular vehicle, basically this is a able or disable type command PID here. And so this is going to allow the system to turn on or off, not necessarily turn that clutch on or off because there is no clutch on this vehicle. So that's not going to help us in trying to diagnose one of these clutchless type systems. So we're going to go over to system test. There again we have generator full field, evap force monitor test, injector kill test, electronic throttle control test. Nothing to do with that clutchless variable displacement compressor. Even under miscellaneous functions, we can learn the throttle control, we can check the VIN, we can check the PCM odometer, we can do some additional tests with the throttle body, but still nothing to allow the technician to test the output controls of the ECM to the compressor solenoid. So now what do? That's where a tool such as the Temp Select comes into play. It's going to do some very cool tests that allow the technician to quickly determine if the solenoid's okay, if the compressor is functioning properly, or if the ECM is giving the proper commands. Let's hook the tool up and take a look at it. And the first thing we need to do is plug it into a power source. Now if the battery is accessible, go for it. In this particular case, you'll notice I've hooked it up to the battery jump start terminals located on the strut tower here. So the tool is now powered up, and next thing I need to do is determine the male and female connectors which are applicable for this particular vehicle. So I've already done my homework here. See, I've got the two connectors. In a minute we're going to go down to the compressor, disconnect the solenoid. I'm going to plug one of these into the solenoid, one of them into the vehicle's harness, and then I'm going to plug them into the tool here. What that's going to allow me to do is a resistance check on that particular solenoid, and it's going to allow me to command the solenoid myself and return it back to normal mode to see what the ECM is actually commanding. And I've got my AC pressure gauges hooked up, and we're going to see if the pressures correlate with the commands on the compressor here. If nothing changes as we command it, that lets us know that we've got a faulty compressor. Or if we do our resistance check and we find that it's an open circuit, well, that lets us know that we've got a faulty solenoid or a faulty compressor as well. And we're going to monitor what the ECM is commanding to determine if it's sending the correct signals. Well, let's go down below, take a look at that compressor, and hook up. Now looking at the compressor, we can see that the control solenoid is on the back side of the compressor here, and so we can get at the connector relatively easy. Depress the tab and lift it out of the way here. And now I'm going to take my connectors and plug them in to the harness here. Once I've got them connected to the vehicle and to the compressor, I'll take the connectors on my tool and plug those in place as well. Now that we've got our connections made to the compressor and to the vehicle itself, we're going to do a resistance check here. I haven't turned the key on or anything like that. I'm just going to hit the check resistance button here, and you'll see the resistance of the solenoid is 10.4 ohms. Now that's well within range. We want to see between 10 and 14 ohms typically of resistance on most electronic variable displacement compressors. You might want to refer to service information to find out the exact spec for the vehicle you're working on, but 10 to 14 ohms is the typical range we find in most vehicles. Knowing that that is okay, now let's start the vehicle up. I'm going to watch my pressure gauges and do the various ranges of control here on this particular vehicle. Now you can see we've got the vehicle running here. I've got my pressure gauges hooked up and I've got my temp select tool hooked up. Judging by the pressures shown on the gauges, there is some refrigerant in the system here, indicated by the static pressure shown here. And if we look at my tool, it shows in normal mode 0%. That indicates that the ECM is sending zero signal to that control solenoid trying to turn it on. Now I know I've got the system turned on max AC in recirc mode. This thing should be pumping. For whatever reason, it's not. And we've also got refrigerant in the system. So I'm going to switch over to manual mode here and hit the up arrow several times, increasing the duty cycle here from the tool to the compressor, turning it on. And we see our pressures begin to change here on the gauge. That's indicating to us that the compressor is actually working. It's able to pump the refrigerant through the system, build the pressures, and start the cooling process here. Now if I go back to normal mode, we notice that our gauges drop right back down to those static pressures. So right away this tells us, using the temp select tool, that the compressor side of the equation is okay. We need to go back to the vehicle side and determine why the ECM is not commanding the compressor on, if you will. Hopefully now you understand the benefits of owning a temp select tool and wish to own one for yourself.